So taking a look at this example, this is one that we've actually done before, but we're actually going to do it from a slightly different approach this time. And really, we're just going to talk about some of the things we learned and how they relate in terms of triangles and parallel and perpendicular lines. And so looking at this same example we've looked at previously, a carpenter's building a stair stringer, which once again is the thing that you cut to support and create a set of stairs. And it says they use 45-degree angles for each cut. Explain how you know each step will be perpendicular to the face of the stair, and explain how you know each step will be parallel to the next step. And so once again, when we kind of look at this example, so here's a piece of wood, and the red line is kind of the pattern that they would cut into this thing in order to create the steps or the stair stringer here. And so as we kind of zoom in on a piece of this thing, what we know is that what they're cutting here is 45-degree angles. So every time they make a cut, it's a 45-degree angle. And so right away, that's how we know that each of the stairs is going to be parallel to the next, because they're all going off at the same angle. Remember, that's how we discover if lines are parallel. Parallel lines always go off at the same angle. So if every single one of these steps is going off at a 45-degree angle from the original piece of wood, then they're all parallel. And we know that. But the other thing showing that the back of the step, the rise on the step is perpendicular to the run. In other words, the step itself is perpendicular to the face, that this piece is perpendicular to this piece. All right. The last time we did this, we had to use some angle addition and that kind of stuff. Well, probably an easier way to look at this is we just look at this piece right here as a triangle. And we think about the triangle that we've created here. Well, we know the three angles inside a triangle have to add up to 180 degrees. And so if those have to add up to 180 degrees, well, then I can take these guys, which is 90 degrees, subtract that from the 180, and that leaves me with 90 degrees, which means this angle right here is a 90-degree angle, which means that the step and the face of the next step are perpendicular, okay? And so that's actually an easier and quicker way than what we did it previously. Previously, we had to use our knowledge of lines and perpendicular lines and angle addition, some of that stuff. Well, here, understanding that I've formed a triangle actually makes this much easier to show and much easier to ensure that I have a 90-degree angle at that corner. Okay, and so it's the same example, but using some of the new pieces that we've learned as our explanation. All right, so once again, we know the steps are parallel because they're all going off the same angle, that 45 degrees from the original. All right, and now we can show that the step is perpendicular to the face of the next stair. The face and the steps are perpendicular because of this idea that I've formed a triangle, and with this triangle, the values have to add up to 180 degrees, okay? And the other thing that's important here is we don't necessarily always make these 45-degree angles, all right? A lot of times we want our steps to have a longer run, a longer flat piece here than we have a rise over here. And so we'll use different angles to construct the stair stringer. But we can still ensure that all the steps are parallel and that all the faces are perpendicular to the step itself. Okay?